Oh, I should probably ask, maybe once more people get here, but kind of the plan and what my thoughts were on this were through since we're doing the Google Air, it'll automatically go up on YouTube afterwards, and which means uh, your your faces will be in that video. Um, it's a Creative Commons license, but if anyone has any issues with that, just let me know or send me a message. I I definitely have some control here as far as like showing and hiding people. And in the last one, like no one even showed up, but I noticed when I went back and looked at the first video. Um,
Yeah, I'm good with it. I paid all my traffic tickets, so I can
oh,
show my
okay.
publics.
Yeah. If anyone has any outstanding felonies or anything, just figured I'd ask.
But on that topic, how in Google Hangouts do you show an image instead of your camera?
So, yeah, I've had some trouble with Hangouts. I think I'm starting to get the hang of it a little more. But one thing that works for me is I use the extension. So whenever it launches, it opens up like a new window in Chrome, and then over on the left, there's some kind of in-app. Um, there's some micro apps that are embedded inside of it, and one of them is called Screen Share. I don't know if you can see it. I'll just drag the side of my window because we'll get a recursive video thing. But if you yeah, see that happens.
Yeah, yeah,
Right
I can.
here.
Yeah, I can see what you're talking about on that left-hand side with the.
Yeah. Sorry about my face forever that you're probably seeing right now.
Yeah.
But yeah, you just pick a screen, and then I think I get the option of like present to everyone, but I'm leaving that off for now, so that way if anyone wants to participate, it should automatically like switch over to your feed. Um, wow. I'll just bring that over here.
Wow.
That's recursion right there.
Yeah.
Cool. I was looking at this Wikipedia on lambda calculus because I heard a definition of a lambda that made total sense, and I'm wondering maybe someone knows the answer to this, but I'd heard like the arrow function referred to as a lambda, but I didn't realize that was just meaning it was an anonymous function. So um, I understand now that a lambda just is an anonymous function essentially. But does anyone have like a better definition or like know anything about this topic? I think it's kind of interesting.
Never heard of it.
I'm in that boat too.
So lambda calculus was invented in the 30s by this guy Alonzo Church, um, along with Alan Turing's Turing machine, and it kind of turns out that they were doing the same sort of things. And this whole, I mean, functional programming in general just grows directly out of what this guy Church was doing with currying and um, composition and passing values.
Should have known that.
So,
Yeah.
so is there a connection between the name for a lambda function, the anonymous function, and that lambda calculus, or is it just a coincidence?
I think the two are interchangeable. That's kind of what I'm trying to figure out, if it's a domain specific definition or if it's a more general definition. I'm not sure. If t is a lambda term and x is variable, then lambda x sub t is a lambda term called a lambda abstraction. I don't know. I'm going to read this later, but this will probably be one of my one of my picks for later that I'll post if anyone wants to look over it. It's definitely something I've been hearing a lot as I begin my understanding of functional programming. And we're not going to go into that much into the weeds. I'm much more likely to say something wrong and mislead at this point, but yeah, hopefully in the future I'll be able to grok. Let's see. Hey, what's up, Paul? And Alexa?
Hey.
Hey. Let's see. Okay, we got 7:36. I'm personally, I went to that city council meeting last night and only got 3 hours of sleep. If anyone wants to steer the boat here, feel free. I would love to just listen. Otherwise, I can kind of cover, I think, the beginning couple topics and begin talking about that stuff and see if any questions come up.
All right, yeah, sounds good.
Okay. And yeah, jump in at any point. What did y'all think about this chapter?
It seemed pretty cut and dry to me. Honestly, well, I guess I've already read it and I read it again, so.
Yeah.
Yeah, it's pretty straightforward, I think.
One thing, I don't know if can we just jump around and talk about weird stuff?
Yeah, sure.
Oh yeah, one thing I didn't quite get what the point of was closures.
Mm-hmm.
And let's see if I can pull it up. I just don't understand what the point is, or why is it even a thing? It makes sense, but why? Why would I use it?
So, why would you? Yeah, I mean, yeah, it is kind of a confusing topic.
Or it kind of seems like a constructor for a function.
Yeah, I think it has to
Yeah.
do with you don't really get a choice. It's not like you can or cannot use closures. Closures are what you're doing when you're writing a function. Because of how that function gets evoked. Meaning that variables are created when they're called from the call object, and it supplies those values that get defined inside of that function at the execution time. So it's kind of like it's getting that it's making a copy, and since a copy means that value is existing in two different places, we can say that the function, the definition inside the function is enclosed, so to speak.
Hence closure. Okay.
Yeah.
Well, I'm just not sure. I haven't seen a reason to use it in my limited experience. So I guess I'm just why is it important? I even hear the word often, and it just doesn't seem that important to me. But I guess I'll come across once it gets to be important. I don't know.
Yeah, I mean, I'm riffing on that definition there, but there's a really good. This is a free book. I'm probably going to look at this some more, but this chapter 5 specifically, goes into scope closure, and
Yeah, I
Let's
mean,
see.
my simplistic, view of it right now is like if you're using a function to create other functions. So like if you had a function that that created another function of x plus n, you could feed it, you could create it with a bunch of different n values, and have all those be distinct functions like
Mhm.
x plus 2 or x plus 5 or whatever, and they'll all have an independent existence.
Yeah.
For me, as far as like a very basic understanding of closure, it's kind of like what Dan said. Is it's just it's happening already, and on an intellectual level, I understand, but as far as like a deep understanding, I wouldn't know how to take advantage or use a closure for a specific purpose. If that makes any sense.
It makes sense. Well, maybe we'll get around to knowing why. Like I said, it's like kind of like an object, like a class would instantiate, I guess, just a basic object. I'm not sure. I'm going to read this chapter, like you said, Dan, chapter 5 here.
Hmm.
And this is probably going to be a good resource.
Yeah. Like one important thing is when you have a value inside of a function that we need to get to, you have to create like see let's I think this example will clear this up. Okay, so we have this function foo, and it has a variable a equals 2, and then inside of function foo is another function bar, which logs a. So and instead of 2, this could be something else that gets passed in, and then there's more calculations. So we're returning a function rather than returning a value, and this function's job is to return this inner value, because this um, this that interesting. Should have read more of this, but like the if we have an
Well,
example.
you're on the right track with that example. But like if you could imagine, instead of having a, you know, always equal to 2, if you had function foo where you're passing in a, right?
Yeah.
You could create a bunch of these all with that return different values.
Mhm.
Yeah, it's always going to be the top one that returns the right values, right? I mean, with the way the scope works, Node School has a really good one, like good exercise on that. I can't remember which.
Yeah, scope
Yeah,
chains and
yeah.
closures. Yeah,
Yeah,
I had just started that one.
there's functional programming, um, like workshop, I guess. Yeah.
Yeah, I mean one way to think of it is a function that I mean a function that returns a value, but it's the only way that we have access to this variable from outside of it, because it's like how can this global scope have access to this variable, and that happens because we're returning.
Yeah, and that's the only way.
Yeah, and that's the only way. Like I can't call on a from outside of it. I can only.
I mean, you could, but it would be a different A.
Yeah. Or
Right.
it would be undefined.
Yeah.
Um,
Well, it's like you've frozen that function bar, with
Mhm.
with a equal 2.
yeah. Yeah, I think that's actually the terminology that they use in this chapter. It's like, imagine you're returning this kind of frozen
Hmm.
function. And then, well, I don't know if this is worth showing, but it did remind me of this object.freeze, which is this new method on the object in ES6, and a lot of times, or I think what we're going to see more often is, I wonder if there's an example of it. When you actually are returning that value, like here, you would actually return object.freeze bar to explicitly say that like this is a set value that I want to actually explicitly protect and not allow to change. Which like JavaScript doesn't get a lot of immutability out of the bag, but this kind of adds that in. So with this, you have to actually unfreeze if you want to change that value at any time. I think it's unfreeze. Oh yeah, we get it. Is frozen, is sealed. I guess that's all. I haven't actually used this at all. But it seems, I mean, if you were doing anything with like banking logic or anything where you were really concerned about that value, then object.freeze on on the return value of a closure seems like a really handy thing. And that's actually like, this is coming straight out of a Douglas Crockford talk that I watched that was called like The Better Parts.
Mm-hmm.
He wrote that book, the Good Parts.
Mm-hmm.
And he gave this this example. So yeah, this is from like 2 years ago or something. And he gave this example of like how he's writing functions now, and he's using object.freeze quite a bit.
Interesting.
Prevents new properties from being added.
I think that'd probably be. I can't really. Once again, I would need to use it, and I need to figure out how to use it.
Yeah, I mean like.
Well, yeah, just to understand why. I could see maybe if you were developing a really user interfacey website, maybe it's an exposed variable or object somehow. Maybe with APIs or something. I don't know. I wish I knew how to use these things. Well, I guess right now we're just learning about functions, so.
Yeah, no, I mean, you will totally get this.
Yeah, we'll get there eventually. Yeah.
See, I was trying to write something here that had to do with that. But what is that one? I'm just gonna copy this. Yeah, cannot assign read-only property.
What did you try?
I just copied in this code example from the object.freeze.
Gotcha.
Just wanted to kind of look at what it does, but
Doesn't work yet. All right.
yeah, I mean it's actually using object.freeze here, so I guess you don't even need Babel for it. It's already in the browser. That's what that looks like. Yeah, does anyone have anything like when you think of closure or someone says closure, like what where does your mind go?
Pops into your head?
Yeah.
Yeah, I mean, to me, I just relate it to scope. I guess it's not exactly the same thing as scope, but it's kind of that same territory.
Yeah.
Is it really just to define local variables that aren't accessible? Is that the whole point of this?
To return local variables.
Why not just rename the variables? Okay, I kind of get it. Because, okay, it's making sense to me now. All right. So, like Jay was saying, whenever we make the various functions from the closure function situation, we are defining new local variables, but we still like want the same functionality of it. We just want different variables for it.
Right.
So instead of, I guess there's no other way to do that.
Right.
What an interesting situation. Yeah, it still seems pretty limited use. I don't know. What are the chances? Like, why not just make a function that takes an additional parameter?
Well, I mean, anytime you're making a function, you kind of are doing, like, you're scoping something.
Yeah, I can see that. All right, so let's look at the example in Eloquent JavaScript. Let's see what it is.
Yeah, that's a really good idea. We just go over this.
I skipped a lot. It's about halfway down the page.
Yeah.
All right, so
I think that question in the first paragraph there really captures it. What happens to local variables when the function call that created them is no longer active?
Yeah.
And in this case, it's like if you're returning a function out of that, if the return value is a function, then all those local variables are frozen inside of there.
Yeah.
But what happens to the function? Isn't the function just another local variable?
Well,
I guess it gets assigned to the
I mean, you're using a function to create functions, right?
I meant the inner function.
Like in that example, in the wrap value, you're passing in a value of n, right? And that's the part that gets frozen. But then if you look at the return value, or return function, I mean, you could make that have a parameter too, which wouldn't be frozen. Like when you call that thing, you could pass something in too.
Yeah, I've seen examples of that.
But I'm kind of like you, Alexa. It's like, why is that better than just passing both things into a regular old function? What's the advantage?
Maybe it's a speed thing. I wouldn't think to do this. I guess don't repeat yourself, that kind of thing. But really, you're just making two. In this case, wrap 1 and wrap 2 are just two global variables that you're setting that you could have easily set by just passing in the value of 1 and 2 to. I guess the wrap value is a really bad example because it's so simple. I guess let's look at multiplier and see if that's.
It doesn't really do anything useful.
Yeah. And even the examples at the end of the book aren't really closures, I don't think. I think there's 2 recursion ones.
Okay, there's one like I was talking about, that function multiplier. You can create a bunch of different functions, each with a different factor, and then pass number into them.
And once again, we have, why not just have multiplier that takes a factor and a number parameter.
I think that's the good research topic for next time.
So did we have a research topic from last time?
Well, in general, it's a good practice to break out every piece of logic that you can. So this is like a pure function that just does one thing. So you can use like multiplier with another function that adds or something. That's interesting, though.
I don't know.
It gives a good example of of how the scope works, within functions, but. So what is the practical value?
I mean, yeah, this sentence is pretty good. This behavior not only frees you from having to worry about lifetimes of variables, but also allows some creative use of function values. I mean, what happens if we just call twice with no param, so we get nan? Because it's going to say nothing times factor.
Yeah.
Only do 2. So,
So what does he say down there at the bottom? Returning freezing the code in this body and wrapping it into a package. So when you return function, think of it as returning a handle to a piece of computation frozen for later use.
yeah, what? So it's frozen because that value is stored at the call time, like whenever that object gets created, that value is made.
When you return that function,
Yeah.
then then like in the example, factor is frozen when you return it.
Which one are we on? Multiplier?
Yeah.
Yeah, if you look at multiplier.
Yeah, all it's really doing is returning this function, synonymous until it's named, I guess, with factor equaling 2, period.
Yeah.
So I really can only see closures as constructing functions, constructors for functions. I think constructor is a real word, though, so I don't really want to use that.
I mean,
Like a prototype or something, I don't know. I can only think of coding words. A skeleton, a function skeleton that you can then add more things onto.
I mean, this just says returning a handle to a piece of computation. Frozen.
See, I think somebody must be worried about variable life, because I'm really not, as a person, not worried about variable life.
Well, think of something, I mean, imagine if this is a stream, say.
Okay.
And, instead of just a static value, it's a changing, a changing stream of values. Then
variable life's more important when you become one smaller part of a large series of interconnected programs. So that you want to sort of keep it compartmentalized to the part that you wrote.
Yeah. This is my friend Paul, by the way. Thanks for joining us, Paul.
Oh, no problem.
Hey,
Nice to meet y'all.
Hey.
Sorry I'm a little late.
Oh, this is the other Paul. We have 2 Pauls now. Sorry. And they're both Paul G's.
Oh, fun. Yeah, I'm a computer science student at UNT, and I'm going to finish my senior year next 2 semesters.
Alright, so you actually know computer stuff. Alright, cool.
Yep.
Yeah.
If you can go ahead and repeat what you said about these variables, that'd be great. Cause
Yeah.
It's hard for me to come up with exact examples, but basically what I hear, trying to declare local variables and keep your variables within a certain, only be used in the scopes that they need to, so that when your program's being called at the same time as other programs, there's not a small chance that like a global variable will have the same name as a variable from one of the other programs.
But can't you do that with just modularization?
I mean, probably, but like I said, I haven't run into too many of the circumstances. That I'm just repeating what I've heard several times over.
Super compartmentalized. Alright.
Yeah. Yeah, you don't want to have namespace collision. That can be really hard to debug.
Here's another scenario I thought of. What if it took like 100 arguments to set this thing up? You wouldn't want to pass it 100 arguments every time. If you could just, if 99 of them were fixed,
Yeah.
How would you? I wonder how you would write this with like a as a curried function. Do you know what I mean? Where like it would return.
Nope, I'm not sure you're talking about. I'm out. Nope, I don't know what a curried function is just yet.
So
Yeah, I've been looking at a curried function, so this would be kind of cool.
Yeah.
All right, can we just look up a definition for curried? I mean, because I don't know what it is. Does anybody else not know? Or I can just Google it myself.
No, I don't know what that is.
Great.
I don't know.
I couldn't explain it.
I'm gonna go for it.
No, I couldn't.
Oh, okay. So I'm just going back to this lambda calculus Wikipedia, and so they have this kind of like example function that they're working with.
Hey,
And
can you
then-
zoom in some, Dan?
Oh yeah. Is that better?
Perfect. Thanks, bud. You can't see it.
Yeah. So this is a function that is applied to a function.
Hey, Dan, you got a little feedback.
Yeah, I noticed that. Might be still there.
Might be on my end.
Test. Okay, cool. Yeah, so you got this. We have this function x. And I'm not really sure what the word for this. If it's like you should say apply. I mean it. This is kind of like a pseudocode type signature kind of thing for like x is a function of y of this other object, which has a y function that takes an x, returns x times x, and then plus y times y. But basically, like, if I didn't supply an x, it would still return y. You know, so that's one way to say, like, this function could be evoked without both parameters and still return something, which is one kind of side of currying. Like, that's not, certainly not all of it. But,
Okay.
yeah, just this method known as currying transforms a function that takes multiple arguments into a chain of functions, each with a single argument.
There seems to be a pretty good article on SitePoint on currying.
I've looked at that SitePoint article before. It's probably the most like clear and concise out of all of them. Also, there's a Node School workshop just straight up on currying, I'm pretty sure.
Okay, I've definitely not gotten that far.
Sweet. Yeah, me neither. Ugh.
That echo is back.
Sorry.
The Wikipedia page describes it very exactly, but use like it. Yeah, I think there's somewhat more simplified explanation.
Is it user friendly?
No, not at all.
Yeah. Yeah.
But
It was
I found a
introduced
good
by Gottlieb
Stack
Frege.
Overflow question that basically asked what is currying, and then someone gave a very short, brief, but detailed answer.
Oh.
I put that in the group chat.
Oh, sweet. Hey, Paul.
Yeah,
Do you have headphones?
I do. Oh, right. You guys can hear yourself.
Yeah.
There we go. That should be better. Sorry about that.
No, you're all good, Paul. Yeah, okay, so this makes sense. I'm just gonna, I don't know, copy and paste the example given, in case nobody else went. I don't know why.
Yeah, you know it's like a hardcore functional term when it's derived from the name of the guy whose first name is Haskell. And you can also call it Sean Finkelization is the other name for
I'll stick
currying.
with it.
It's also a Sean Finkelization. I'm not kidding. But currying is a lot nicer.
I guess it makes a lot more sense when you're calling a function a lot, and you don't want to have to type out all of the parameters if there's a bunch of them.
Yeah.
Or if you don't need it, I guess. Oh, I guess in this case you are returning something. Or as an extra layer to what closures? What if you want? can't even think of a good like if you have this crazy I guess like a physics math problem where you had various constants, or maybe you choose one or two different constants. So you would put the constants in the equation and then pass it different variables depending on whether or not it's doing some physical thing. So you would make it a closure with the constants in place, pass a couple different of these variables in with the currying, and that way you have closures and currying one function application. I can see it happening.
Sorry. I'm not even gonna mess with it.
Okay.
I still want to look. Yeah, I think currying is this really, really powerful thing. It lets you kind of write in this high level of just kind of like saying the things that you want to do to a set of data, even when you don't have all the parts of it.
Yeah, absolutely.
So you have libraries like Lodash that are really they're designed in such a way that you can compose. Does compose does that make sense when I say like compose, like if you compose two functions?
Nope.
Okay. So like say
Are you talking just like the same as in the mathematical sense, like
yeah
like f of g
I'm not sure
of
the
x,
difference.
that kind of composition?
Yeah, like if I have let's see, if I have like one function that like say takes a and returns like a times 2, and then I have constant b that takes takes a b and returns b plus 2. And then or let's do this. This one will take b and a c, and it returns c. So I can effectively do like func a of func, or func b of func a 1, and then 3. It's not returning anything. What's it not returning? This should get executed first. Oh, maybe I have to console log? No.
I think you do, or return. Yeah. Oh, I don't know about that, but are you actually returning b plus c, or is that just happening in the function and JavaScript forgets about it?
I mean, that looks like it should work.
Yeah, that should work.
Yeah.
Right? Okay. So what should be happening, I'm invoking func a. That should be 2, and then this gets called. So it's like this isn't getting called at the right time. I wonder what happens if I do like oops, consoles. Oh look, okay, it just wasn't returning. Yeah, it does say 5. So this isn't really composition. This is more just function as an object. Like function as a first class object or function as a value, where I can pass in a function as a value. But imagine that these had more properties, where this was also a function that was taking up some parameter, and then I could maybe have another function that takes other parameters, and these things can all compose together to return one value. And that's kind of one sense of composition. I can do like, or like say I have a set of values. So I make an array, and then I'm going to call the native .map on it, and just return just the map function I want to do. Good example. Struggling to come up with a good example of composition, but I mean, you even see it in like front end stuff. I mean, I think that first example kind of is the essence of it. Just imagine that these are more complex functions that are doing more things, and I can potentially be calling any number of functions, but still just returning one value from them.
Yeah. He covers composition in chapter 6, I think.
Oh, cool. Okay. Then I will table that for now.
Maybe not. One sec. You can still table it. We could.
Yeah, I mean that's going to be something that'll come back a lot, especially when it comes to using libraries later on. Like if you're looking at like libraries that provide data to other libraries that are like view layers, and you need to pass that data to the view layer somehow. A good way of doing that is through composition. So you're kind of calling you're calling your view function with the results of this like get data, and it's just filling in all those blank spots.
All right.
Y'all want to talk about recursion?
No. Apparently. Let's see.
Oh, yeah. Did anyone do that assignment question on the end, or that exercise?
Yeah, I did all the exercises for this chapter. Recursion is still something that I cannot bend my brain around, to be honest.
Yeah.
Yeah, I've got a solution for that one if you guys want to see it.
Sure.
Yeah. I have them all on my, or at least I have the chapter 3 one on my code pin.
Oh, nice.
Have you tried the Code Academy Recursion JavaScript class?
Is there one on Code Academy?
Yeah, I just took it last week. And
Is it, I mean, how do you feel about it?
It's a whole class?
I mean, I'm still confused. It's kind of like all the other ones, but it helped clear out a couple things. You kind of got to treat recursion as a for loop, kind of, or a while loop. That's think of it that way. Then it made it easier for me. That was what I was.
Yeah, cool. Well, I'll definitely check that out because like I'm trying to use every resource possible to get there.
I'll post a link.
What sort of problems did they have you solve in the Code Academy recursion class?
They had you do the factoring. They had you do a loop through an array, push onto an array, use recursion, a couple others. It was pretty easy up until the end. It got kind of confusing, but it's easy to work through. It's just hard to wrap your head around some of the end stuff because they get a little advanced. It's not anything crazy, but it does get a little advanced.
Because I didn't really have to use recursion all too often until I started running into various search functions on binary trees and graphs. And especially in terms of graphs, when you have no idea what the function's actually, like how big it's going to be, it helps you to create a loop where it just ends whenever you reach that certain condition.
Yes.
So that's when I started finding it more useful. It's still really hard to use, and you have to sort of make it situationally, and you have to absolutely make sure.
Something you just said kind of made sense. Like, I guess the point where you need to loop it until it reaches a very specific condition.
Yes.
Yeah.
Oh, that kind of clicks something. I don't know. That clicked something for anybody else.
I'm showing this chapter 3 recursion even odd problem. You want to take a look?
Cool.
Yeah, and I think this was a pretty good example of what you have to do to make it, to make it stop recursing, because all you have to do in this one is just count down. Every time you make the recursive call, you're just calling it with, one less than what you started with, until you get down to, if you get down to 0, you can return even, or if you counting down to 1, you can return odd.
Yeah. This just seems like the worst possible way of finding odd.
Yeah.
I mean, yeah, you could always just use a loop, and it'd be a lot easier, but the simplest examples aren't going to need recursion, and then all of the more complicated stuff needs its own chapter, where recursion would actually be easier.
Yeah, really, the recursion, you don't really need something like that unless you're trying to traverse a tree, or some structure like that.
Somebody on Reddit a while back, I haven't really. Some of it was like a little too high level for me because passing like more arguments than a function could take is a little too high level for me. But somebody posted that on Reddit for me. I posted it in the chat.
Yeah, talk about recursion. I've got it in spades now. I'm gonna get out of this.
Yeah, just need practice.
Jeez, man.
That's what happens when you forget to set a terminating condition.
Okay.
Right. Yeah, that's actually that's one example that I could. Oops. Wait. Now I forgot how to share my screen. Here we go. Okay. So yeah, like doing like a tree here, like a file system, say, and you want to say you have like a two-dimensional array or like a mini-dimensional array, and you want to display like a label for each entry in that array. In that array. So one way to do it is to recursively. I feel like I have to say the word loop, but call that display function over and over until the array runs out of nested arrays. Which is actually what the guy is doing here to make this this file tree. And there's an example of it, but let's see how dependent on doing Meteor this is. So he's got this template, and it's like, if there's a category, then show this other template, and link to it. So each category is. it's not really clear right there.
If you go back to that go up twice to the cats, my category is cats. Boom. He's calling my categories cats within my categories cats here.
That's right.
We are looking for recursion, right?
That's it. Yeah. Yeah.
Perfect. Boom.
Mm-hmm.
Cats. Oh, categories. Okay.
Yeah, cats.
I was like, how many cats do they have? But yeah.
Yeah. So if that member of that array is another array, then it's going to call this again. Yeah, and that's a function that he's using here for this thing. It's kind of neat. It's actually a pretty
It's probably a smart way to do it.
yeah. I mean, otherwise, you'd have to almost make like a state machine or something to handle, all the levels of nestedness and whatever your data is. And doing it like this just means you write one template, and then if it has
Right,
it,
exactly.
you display it.
And they all do the same thing, so there you go.
Yeah. And then once it runs out of items, then it's just you're at the end. And specifically for like taking something like the not the finding min, this one. Like say our number is a million. It's like it would have to go through half of 1 million to return the value from here, and that just seems so insane to have to call the function that many times. But there's a thing in ES6 called, I mean, say it's more than that too. Like say you write this factorial and you're running it on like a gig of data, or more. I think the max right now is like 2 gigs before you just like completely buffer overflow and can't do any more computation. But there's a thing in ES6 called proper tail calls, where it's kind of able to keep track of where it is in the computation, and if it's a giant set of data like that, it can kind of jump to the end and save you a lot of time. So writing a recursive function like this in ES6 won't be 10 times slower than doing the for each, like you mentioned earlier.
All right.
I think that's what it's called. Tail calling. Yeah, tail call. Blah blah blah. Links out later. That was one of the things I did notice he talked about. Yeah. But this implementation has one important problem. In typical JavaScript implementations, it's about 10 times slower than the looping version. So it used to be the case that when you wanted to make really high performance code, you would rewrite to just use for loops, and rather than like map functions or recursive functions, etc. But now it's that should be fixed.
Okay.
I'm trying to remember, do they cover Big O later in the book?
I think so.
Because that sort of helps you get, like, if you see an example of Big O on a recursive function as opposed to a loop, it becomes very clear how quickly they run in difference to each other.
Right.
And if you really mess up the recursion, you can have an absolutely terrible program running time.
Right. So basically that depends on the type of operation you're doing.
That too, yeah.
Because if it's just like an add or subtract, then it's just that linear.
Yeah.
Okay.
But for example, like let's say if instead of that return you had the recursive function, and then again in that return you called the function again, it would have to
Yeah.
call through the recursion twice. And however many times it does loop through that recursion, it's calling both twice. So
Yeah.
things like that make it grow a lot.
And the other, what's the? So I like just read a little bit about Big O notation like 2 days ago, and
Yeah.
the main thing I got out of it was,
You basically just count the lines of code, but you try to break down the lines of code into a mathematical formula. So if a loop runs 5 times, you count the number of lines of code in that, you say all of that runs 5 times. Like 5 times that number. Of course, because you don't want to actually count every line of code because that's really tedious, you sort of make an estimate based off of just looking at the loops and looking at the recursive parts and saying runs in big O of n squared or something like that if the recursive part runs through squaring itself.
right. And that's called it. Does that have another type of growth, or
What do you mean?
is that referred? So you can have like an exponential.
Yeah, there's different types of growth. It's not always exponential. Like, could try and find a.
Or like, yeah. Do you are does anyone not know about Big O notation?
I think that our
Like, it's not too
computer science
important now. I was just mentioning for
4 weeks.
recursion, it becomes really important if you want to start using recursion more often, just to tell if it's something that you need to use.
Okay.
Will you say that again, Paul?
Yeah, if you want to use recursion, you have to be very careful to be able to sort of figure out how long it's going to take, and Big O is useful for that.
And so basically what you're saying about Big O is it's the amount of lines that you use in the recursion squared?
No, it's like, let's say you run a function recursively,
Yeah.
and it's calling itself.
Mm-hmm.
Let's say it has to call itself 5 times, so then it runs through that code.
Oh, okay.
Like, let's say it's 5 lines of code. You're running 5 lines of code 5 times, so that's 5 squared.
Yeah. I got you. That's Big O.
That's not the best explanation, but that's sort of what I'm trying to get. Yeah.
I'm definitely picking it up.
So would you notate that O of n squared?
Yeah. If it does that, it's a lot easier to tell what you're getting out of for loops and stuff. Like if you have a loop nested inside another loop, that first loop winds up squaring the second one if they're both running off of the same variable. Like if they both have their terminating condition set to I,
right,
and the inner loop's the one that increments it, and then once that loop finishes, it increments the I for the previous loop. Or the counter for the previous loop.
Is that evoking the outer counter in that case, and then calling it again? Because I thought like the inner one would execute and finish first.
No, that's what I meant. Sorry. I'm getting a little confused about the inner outer part, but basically whichever loop is nested inside the other one. So the one that finishes first.
Mm.
And then increments the loop for the outside loop.
Right, but then the inner, each time the outer one is called, the inner one runs all those times again.
Yes. And situations like that, you wind up squaring things, and then or in some cases, if you're having it move the counter up every time the outer loop counter goes up, it winds up being a factorial instead. But
yeah. And then a factorial is...
It's just like, let's say you have 5 factorial, 5 times 4 times 3 times 2 times 1.
Right.
I remember seeing that big O notation, like in relation to sorting, right?
Yeah,
Mm-hmm.
the various
Yeah,
sort functions.
like if you have a data set of size n, then different sorting algorithms, you could have it, be
Yeah,
related to the size of the data set. Like if the data set is size n, you could have a sort algorithm that would be of complexity of n squared, or if it was a good one, it'd be like order n, like directly proportional to the size of the data.
Yeah.
I found the Wikipedia. There's a big O notation Wikipedia article that starts out with some of the basic stuff. But it says the big O notation is used to classify algorithms by how they respond to changes in input size.
So you're saying like a really good one would be ON just because it's a linear, or it's directly proportional.
Yeah.
And it's not having any kind of internal recursion or doing one of these insane growth things.
For a lot of sorting functions, you want to try and get it as close to big O of n as you can. It's not like you can really sort through it faster than that, because if you're sorting through n items, then you have to go through some function at least n number of times. But usually the functions wind up, most of the sort functions usually wind up being between big O of n or big O of n squared. And a lot of the ones that were like the initial simplest approach is big O of n squared. They can reduce that to big O of log n. And to figure out why that is, you sort of need to understand trees. But
do you mean trees like TRIE?
Yeah, binary trees.
Oh, okay.
Yeah, because with that they can sort of split a data set up and then ignore a large portion of it if they know which direction they need to look in. So instead of having to look through and sort because when you sort something, you don't just have to look through the whole list at each number. You have to look at each number and then move them in correspondence to looking at the other numbers they're related to. So doing that usually winds up bumping up the time.
Yeah, I mean, you're kind of getting into like tree traversal and how the data is actually
sorted,
saved. Yeah, sorted.
I wound up diving off the deep end by mentioning that completely from where we were, which is just recursion. And I just wanted to mention that recursion, if you need to figure something out on how quickly it runs, you usually have to look at big O.
So you weren't referring to this kind of tree, right? The TRIE, like tries?
No, I'm not.
Okay.
And it looks like there's a form of tree, but I don't know the exact definition difference and what makes this type of tree. Unlike a binary search tree, there is no node in the tree. Okay.
Yeah, this is how libraries like Redux, how they're able to really efficiently make copies of data through basically replacing one item in a tree, but the entire new data set. So if you're, and by data set I mean like it's a state of an application, say.
Yeah, it's interesting because each of the arrows winds up representing a value. So they're like nodes into themselves, but it's a node that always directly points to another node.
Yeah.
Although that would be sort of bad. It gets confusing because computer science reuses a lot of the same concepts, and sometimes you have the same name for multiple things. So.
Interesting. Yeah, deterministic acyclic finite state automation. That's that term I keep hearing. Yeah, acyclic just kind of means
that it doesn't repeat.
Yeah, and these arrows are one direction.
Yeah. Yeah, and deterministic also means that you won't have it going back. It doesn't have choice. Like, it's not like I. There is its own arrow. If it was undeterministic, there would be two arrows that both have I on them.
Yeah. This is how this...
Which any non-deterministic can actually be broken up into a deterministic graph, so...
Yeah, I watched a really interesting talk from the guy who wrote this library, Datomic, and he talks about having it's like a 7-layer deep 32 key tree that ends up being the most efficient the most efficient representation of your data, because basically you can get from one state to any other state within 7 steps with this like 32 leaf tree.
Okay. I do not doubt that. I'd have to look into it to understand it, but yeah, the graphs and trees and various data structures like that, supposedly at first they don't seem to make a lot of sense to why you would ever use it, but it's mostly a way of organizing data that makes it faster for the computer to reach. And it's sort of when you want to start getting into optimizing code that you sort of look at that.
Yeah, because I can just specify this entire transaction just with this pointer.
Yeah, and instead of having to search through all of those options to figure out the one you want, you start with the letter, and then that only leads to a finite number of other letters that it could go through. So.
Yeah. Unlike binary search tree. In particular, a bitwise tree. I'm pretty sure this is pronounced tree.
Yeah, it's probably still pronounced tree, and that's probably just confusing for most people learning the concept or talking about it to people who haven't heard it. But
yeah, I would think like why
if you see
would
it typed, it's a lot easier.
Just name it a different thing. I think it's actually there's a white paper on this and a reason why it's called tree like that. And it basically it comes from the word traversal, or like tree, like traverse.
If you want just an easy to understand, look at data trees, recursion, Big O. That 4 semesters of computer science.
Oh yeah.
That we talked about that one time really covers that pretty well. I've already gone through that.
Oh.
That was actually a very neat page because that seemed to be a general overview of data structures. And I had to take that course in an entire summer, and that's just one page that sort of tells you all of the key points of that.
Well, I will read that after this. I feel like such a dummy for... I'm such a bad student, you guys. I'm really sorry.
Ah, you're fine. It's hard for professors to come up with examples on the spot sometimes.
Yeah.
So it's fun to watch them stumble, and then we actually paid them for it, so they feel a little more embarrassed.
Well, I'm very far from being a professor. But yeah, I'm working from home tomorrow, so I think I'm going to spend a lot of that time just studying. Hopefully, I got to drop my car off. Yeah. Oh, retrieval. That's what it comes from. This.
Okay.
Just to finish that up.
Yeah, that makes a lot more sense.
Yeah. In an attempt to distinguish it verbally from tree, but it sounds exactly the same.
Yeah. Well, clearly you know what they're talking about
Yeah.
if you understand all of the context around it.
Well, look at the phonetic spelling is one letter different.
Yeah. I'm just being sarcastic.
Yeah. I guess try. Okay, some people pronounce it try. I'm going to pronounce it try.
That's best.
Yeah. Look at that. Looking up data in a try is faster in the worst case O of m time, where m is the length of the search string, compared to an imperfect hash table.
Okay. Yeah. Did I say m was the height?
Is the length.
Oh, length of the search string. Okay. Yeah, so that is a lot faster. It's kind of hard for me to say exactly how much, but
Yeah, so I'm sure that's what's like when you type something into Google or like autocompletes. It's probably good if your data is represented like that. There are no collisions of different keys in a try.
yeah, and collisions is talking about hash tables, where it tries to put too many values into the same key in the table. Like, let's say you're sorting it, or you had an array that was 10 numbers long, and each number, you wanted to fit numbers in it that were divisible by that number. So let's say you had 6, it would go into divisible spot 3. Or no, not better. I hate these examples whenever I come up with something and then I realize it doesn't work halfway through. Let's say you had one 5 lengths long, or 5 numbers long, so it's 0 through 4, and any number divisible by that number fits into it. So yeah, you have 6, and then it fits under 3. You have 9, also fits into 3. But that's 2 numbers in the same key. So usually when there's a collision, a hash table will create another array of the same length, and then put that one that collided in that spot for that array, and have a pointer pointing to that. So you know, all right, in the 3 spot there was 6 and there was 9.
And then the rest are just null?
Yes, and then the rest of the values are just null. If you have one particular cell that has a lot of collisions, it winds up making a lot of unnecessary data, and there's a lot of cells that you have to just combine. So that's the downside of that.
Isn't that what kind of got rid of the, like, killed the goto statement?
I'm not too sure. Go-to statements, I think that was something about them not wanting to have to jump around in the memory as much. And that gets down to the lower level.
Yeah. Yeah, a common application.
With go-tos, it's unstructured code. I mean, you could literally make it go anywhere. I mean, there's no, with the kind of structured code we look at now, we've got ifs and loops and fors, and it's pretty much predictable what they do. But you could have a series of go-tos that, it's literally it's just like a big knotted ball of string,
Okay, yeah, so it sort of ties your code up. So anyone reading it, they have to follow 1,000 strings that are sort of interwoven over each other.
Yeah, it could be interwoven in any, just a really complex way that.
Whereas with function names, it's just, I always have to go back and look at this function, and if it goes somewhere, I can follow it easily from there.
Yep.
Yeah, that's where that Dijkstra paper comes from. And it took a long time to get rid of the go-to statement. I mean, this is.
I mean, they're very flexible for the person who writes them. It's just coming back to reading it anytime later, or for anyone else to read it, it becomes very hard to follow.
Yeah.
When I learned programming, I learned it on the TI-83. I didn't exactly get for or while that well, so instead I used a long series of if statements and go-to statements to simulate loops and conditionals. And while it worked for me when what I did, I could see how it would definitely get confusing later on.
Yeah.
Especially since I only got 24 variables to work with. Because it only had that, yeah.
Oh, here's that example I was trying to make earlier. So Paul, what's the? I'm getting another echo. Dang.
I got my headphones in.
I was just gonna ask, what language you were learning in your like computer science or what the main focus was, and if there were things about JavaScript that seem odd coming from another language.
Yeah. I'm mainly learning C++, and it's pretty familiar to someone moving from C++, but there are some things that are different. For example, any function being able to take any number of arguments, that's very different, because in C++, a function is defined partially by the number of arguments it takes.
Mm-hmm.
So you could have a function called like add, and it could accept 2 parameters, but then if you had another function called add, but it accepts 3 parameters, they're 2 entirely different functions. So you have to define them in 2 different spots.
Oh, interesting.
Same thing for types of variables. I looked at a video of yours previously, and someone mentioned that you just have var inside JavaScript. But in C++, you have to define very specific types, and that's true for functions as well. So int add is going to be different from double add, which could be different from, basically like character add.
Yeah.
Just concatenating characters together. So you'd have to write all 3 of those functions if you tried to call those different, and the value that you pass to it. It gets kind of confusing when you do it like that. I mean, and you can make templates for function. So you can say some various specified, like int or double. It doesn't matter which type of variable it is. Gets passed to this function. Then anytime you pass a function that kind of variable, it will do whatever was inside that template on it. So that's sort of a workaround for that. So you can pass something either ints or doubles and always consistently have it be added.
Oh, okay. So you have kind of like
write it multiple times.
Yeah, like a master function that checks the type and then calls the appropriate worker function.
Yeah.
That's a terrible.
Try and think of it like they call it templates. So I sort of like to think of it just like it created a template for it.
Yeah.
And it doesn't matter what type fits into the template. Because it's made to accept multiple types. And it's made to keep you from having to rewrite it each time you want to use a different type.
Okay.
Yeah.
Sorry, I evoked slavery to make that
No, it's very hard to come up with computing analogies. So.
Cool.
Question for you.
Yeah.
Like you've been digging into C++ lately or something?
Yeah, I've been working with it for my.
Yeah. So there was a age-old problem with C++ about memory leaks. Have they fixed that problem?
Yeah. I don't think so. If there's a problem with memory leaks in C++, it's probably due to, well, for one, there's a lot of stiffness with C++ that you have to get used to, and figuring out how memory works with it is just one of the hurdles of C++, where most other the newer languages like JavaScript or Java even basically solve those problems for you. So.
Right. I remember in programming in C way back a couple 3 decades ago, we used to have problems with dynamic memory allocation. There's a system call called malloc, and if you don't clear the buffers, you're going to have issues with unwanted, information in the dynamic memory. So we used to always, my thing was that I always called calloc, which will clear the previous buffers in the memory allocation that's provided to your program, and that way there will be no previously added information in the characters or whatever.
Yeah. I know what you're talking about. It's weird because in trying to solve assignments, I'll still run into examples that use malloc, but yeah, it's a lot better to call calloc because it does initialize the memory.
Right.
I think they're slowly fixing those problems in C++ by replacing old functions. And it's funny because you look up all kinds of examples, and you'll look up functions even in those, and it'll say deprecated, please use this other function instead. So I've heard someone mention JavaScript has a huge library. C++ has an absolutely huge library as well. And tons of the functions in there are just in there to make sure things that were written using them continue working because they don't have time to rewrite all the functions that they were working on that had called that old previous function they no longer want to use. So it's got a huge legacy, and it's not entirely the most user-friendly, but it's what most everything else is based off of. And it works pretty fast if you can get it to work for you. Ultimately, I think something like JavaScript would probably be more practical to learn, though.
Yeah.
And it's just because I'm in an academic setting that they're saying, do C++. There are a lot of good jobs out there that use C++, and it works. You know, it's what a lot of things are written on the PC, so.
Yeah. Well, I could definitely listen to you guys talk about C++ forever.
I've even heard some stuff with like the new libraries that they've released. Some of the functions just not working right because they hadn't been tested all the way through. So.
Well, Jay, do you want to show your solutions for this, for the, or Paul, other Paul? Do you want to show any else solutions for like the bean counting?
Sure, I can show it. Just give me just a second here.
Yeah, no problem. You gotta log in again?
Yeah, I got a couple of virtual machines going here. I have to switch back and forth.
Oh.
Okay, let's see. Bean counting. Okay. Trying to remember what I did here. Basically, it's just a couple of loops.
Turn value.
For count bees. Just step through the array and look for bees and increment the count, right?
Mm-hmm.
And then the second one, count care. Let's see, I forgot what we're looking for on this one, on count care.
You have to accept a character that is to be counted.
Oh, okay.
Like.
Okay, right. So we pass in the string and then the character you're looking for, and then you just step through the array and you know every time you see one you ding the counter. That's pretty good.
Yeah, it should be the same as count B, except the variable you're using the comparison with is one that you accept.
Yeah. The first one you just pass in the string and look for bees. The second one you pass in the character, the string and the character.
Yeah, I see that. S at position I equals C. So
Yeah.
we're doing the comparison there.
Yeah, and let's see.
Yeah, that's one thing I dislike about C++. You can't simply do that in C++. You would have to find a function that says it's like character or string is equal or character is equal depending on what you're working with, and use that usually. It's a lot less user-friendly in that regard. I mean, you might be able to do that because the character ultimately has a number value, and the number values might be equal, but there's some weird behavior.
So in C++, I mean, you couldn't just pass in an array of characters.
Well, an array of characters is.
It wouldn't be the same. It wouldn't be quite the same as a string, but you could just pass in an array. You know, each array member would be one character.
Yeah, this is where it gets a little weird. Arrays of characters were at one point considered strings, and then they made another type called string. So you've got functions that say they do things to strings, but they only do things to arrays of characters. And then you have functions that do things to strings. Figuring out which one is which basically just means looking up the libraries for it and figuring out what it's particularly used for. But I haven't worked with that in a little while. I just remember running into issues with it in the past.
Let's see these other two exercises. We looked at the recurse, and I realized I had it wrong while we were looking at it before.
Oh yeah.
Yeah, actually, supposed to. Yeah, you're supposed to count. You're supposed to reduce the count by 2 every time.
Oh right. Yeah. Otherwise,
I had -1. It's actually in -2.
yeah.
That works. And then the one for finding the min, I mean, that's just trivial.
Yeah, that's exactly what I wrote.
Yeah.
I like those ternaries. I started using that quite a bit more since last time.
Yeah, me too. I wasn't used to using that at all, but it's just it's just so it's so compact.
Mm-hmm.
I mean, if you wrote that with it, within if else,
yeah,
it would
chain.
be with the lines. You would have what, like 4
10.
lines there.
Yeah, like 10 lines. Well, 5.
Yeah.
Yeah. Cool. Thanks, Jay.
Sure.
Well, I know we didn't stay too close to the book this time. I didn't do a good job of studying beforehand and going over the material.
I mean, these first chapters. I mean, there's not a whole lot to talk about.
Yeah.
I feel like everybody's ready to step on ahead and get to some of the later chapters, because there's just not 2 hours worth to talk about in chapter 3. I don't think.
Yeah. Yeah, I think that's why some of the people dropped off.
And we did sort of jump around as well and talk about things that would be important later on.
Yeah. That's one of the things I like about these sessions, though, is finding out the stuff that other people are doing and thinking about that's not necessarily in the text.
Yeah, exactly. I mean, text is just a reference.
Just like that big O stuff.
Yeah.
I mean, that's valuable information. I wouldn't have, I might have gone the rest of my life without thinking about big O, but but now it's stuck in my head.
Yeah, I'm definitely going to read that 4 semesters of computer science in 6 hours. That article. I'm gonna read more of that. You said that was pretty accurate, Paul, as far as.
Yeah, as far as a general overview goes, and actually getting good with those data structures takes trying to implement them yourself to understand how they fully work. Because if you get just 1 or 2 steps out of how a tree searches for a value, then it'll mess up the whole thing. So, but it helps explain it to you basically. Because I thought I'd get a data structure explained to me, let's say. A depth first search. I'd have it explained to me, and I'd try to implement it, and then I'd realize when deleting a node, if I had to delete something in the middle, I'd have to restructure the whole length of the tree below that node. Something like that gets a little more complicated when you're actually working it out and having to have it work for you than when you're just looking at examples. So.
Yeah.
But yeah, if you don't have the time to fully implement it, just write it out on paper and then go through the steps, and that usually helps. And that's usually what a lot of the data structures is good for, is if you run into something, if you're coding something, you're supposed to be able to look at the data structures you've worked with in the past and go, hey, this list of addresses looks somewhat like this kind of array. And then you can store it as that kind of array and use the functions you already know to get the data quicker.
Yeah, I think that's really the value of actually getting a computer science degree, is exposing yourself to a lot of different kinds of problems and then being able to recognize them.
Yeah.
And saving a lot of time.
Biggest issue I have is they show us very disconnected examples of those problems that don't really have real world application. And then it's up to us to sort of later bridge the gap between, hey, this is a real world problem and here are the tools they gave us. They just sort of give you the tools, tell you a bad example of what they're used for, and then tell you how to use them with that. So, like, I don't know how many times we've had to work something out for the Towers of Hanoi, and Towers of Hanoi isn't a good example. Like, or it's a good example, but it's not a practical example.
Yeah, like nobody's going to pay you money for knowing the solution to that.
Yeah, I would love to see that job interview. They have a bunch of disks stacked out on 3 little things. Can you get these moved over as quickly as possible in the least number of moves?
Yeah. Have you seen the YouTube video of the sorting algorithms? Like visualized?
I think I've seen it once before, but I'm not sure about everyone else here. Like, and it was you that showed it to me. So.
Yeah, this is cool. Can y'all hear this? If I.
I'm not hearing the beeps and boops.
Oh, okay. Well, here I'll unplug for a sec. It's really interesting. He put like a harmonic frequency with the height of each one of these items, and then goes through 15 different sorting algorithms. I'll just play one of them real quick. So that's selection, and then this is insertion. So that seems to take a lot longer. Quicksort's cool.
Yeah, and for these, it does depend on the data pool that you get. Like, some algorithms have very similar big O's, but if you have a random sort of data that's just looks like it's disorganized a different way than the algorithm is good at sorting, then it might take a little bit longer. But yeah, selection sort was one of the slower ones. It's just it was easier to implement than, like, say, quicksort.
And then you have hybrids of those, correct?
Yeah. I don't know all of them, so... Like, there are a lot of algorithms, and then there's some of the more advanced ones that take the best parts and worst parts of other ones and put them together. But...
Gnome sort?
Yeah, I don't know gnome sort.
Interesting.
Bitonic or BOGO. But I've written bubble sort before, and done heap sort, done merge sort, did insertion, selection.
Cool. That's awesome, Paul. And everyone. Hey, Alexa.
So.
Sorry if we kind of got off in the weeds there for a while.
I had to leave and come back. It was a thing. I'm back now, though.
Right on. We were just talking about sorting algorithms.
Sure thing, yeah. I cover those a little bit. How many times a day do you need to sort? Right now, where I am in web development, maybe once you get to search and stuff, sorts is like a big intro computer science situation. They're interesting. I think it's more of a theoretical field because there's a whole bunch of sorts out there right now to work with. I don't know. It's fun to think about.
Yeah, I feel like it's just good for my brain.
Yeah, even trying to just work into why does this crazy sort work.
Does anyone here work a lot with SQL or other databases? Because it seems like something that would be useful for that. But as far as as far as I figured, they already have functions written out for selecting things. In SQL.
Yeah, in SQL. I mean, it's already pre-cooked. You wouldn't have to write your own sort.
So and that's something.
Usually in a relational database, you have an index.
Mm-hmm.
So there'll be like a secondary file that that's an index to the data, and you can have multiple of those sorted on different fields.
I've heard about relational databases, but it always comes at the very end of a class, so we never get enough time to actually describe what they are. They're just like, and this is something you'll learn later in the next class.
The relational guy is COD, CODD, and there's some pretty rigorous rules of how those relational tables are set up.
Absolutely.
Yeah, that's it.
Cool.
But like Oracle or MS SQL, any of the popular ones, they more or less are built according to these rules.
Okay.
Sorts to be really useful for just basic data science. Just we have all this.
Yeah. The main idea of relational is you don't want to store stuff more than once. Like if you've got a bunch of fields in the table that's just repetitive data, you want to
Okay, so it links.
Extract that out and only store it once.
It links them together with the keys that they share.
Yeah,
and then it sort of says, hey, all this data goes together in the same. So like if you call the key, then you should get all the data related to that key.
Yeah. So like if you have one big table with a bunch of repeated data in it, you would reduce that to multiple smaller tables. Okay. So everything's only recorded once.
Makes a lot of sense.
Yeah, those kind of things, like I work a lot in a non-relational database, and trying to model those relations can get really tedious because you have to basically define, like instead of having a relational, like a foreign key stored on a table somewhere, you kind of have to keep track of the ID of a separate document on the first document, and then use that to do another lookup, and then pull out whatever fields you need from there, and you kind of have to write all that logic.
Normally, for an easy one, like an example would be someone's name, and then using their name to figure out multiple sort of places in various tables that their name is stored. Like if it's their name and their phone number, and then another table has their name and their email address, you just get it from those two tables when you call their name.
I've been trying to read about the non-relational stuff, and it's so different from this. It's like, if I understand correctly, it's like you can add fields on the fly.
Yes. Schemaless.
If you had a table that was like name, address, and phone number, and then you wanted to add gender, you could just add that. Like the next record you write, you could add that field to it, and everything's still hunky dory, even though you don't.
Oh, totally. Yeah.
Before.
Yeah, I mean that kind of stuff you have to kind of enforce through some other means. You'd have to find some kind of ODM to enforce those things, and then like reject any time you try to make a document that doesn't have one of those fields or is the wrong type. But out of the box, something like Mongo, it's flexible by nature, and then they.
Yeah, I mean that could be an advantage, to be able to do that. It's like if you could have a lot of documents with different fields filled in all in the same table, and I can see the advantage of being able to do that.
Yeah, or even like tracking say you have your entire application state just in one document. It would be really tedious to try to keep track of, or it could be really restrictive even to try to force that into a schema. Yeah, in general, I really like it, and I think Mongo, and there's a few others, like I think.
Yeah, I just set up Redis, and
Redis.
So far I don't understand how it works at all. I'm just kind of started with it.
It's supposed to be really efficient. I don't know if it has document, like Mongo is a document database and Redis is a
Redis has got there's a bunch of different data structures you can use in Redis. I mean, you could use it just like MongoDB, you know, with the key value structures, but it does a bunch of other stuff too in Redis.
Cool. Yeah, I need to look into that. But Redis is supposed to be really good for IoT.
Oh yeah, there you got it. Yeah, strings, hashes, lists, sets, blah 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 blah.
Wow. Sad.
Yeah, it makes me. Yeah, that was my initial emotion.
Cool. Yeah, that's really neat. Trivalent. Yeah, the main I'm if you do end up using Mongo for anything, actually using an ODM is really helpful. It kind of lets you interact with the data more easily. But yeah, I'm not sure what there's probably a Redis ODM of some kind. Might not even need it. GNOME. Ugh. Okay. All right, guys. Well, I'm getting a little bit sleepy.
Yeah, I'm gonna need to drop off myself.
What kind of stuff? Let's look at what the next chapter is.
It says data structures, objects, and arrays. It actually looks pretty interesting. I was skimming it a second ago, and it basically looks like a lot of different functions that you can use on data sets that you have, like map.
Oh yeah.
Sort of step through them.
This arguments object is really interesting too. It's a native property on a function.
Argument.
And with the splat operator, you don't really have to use it anymore.
Oh, is it sort of deprecated? There's something like it, but more useful. But right now.
Yeah, if you use well, if you need to call something like arguments.length, you can't use the rest operator for that. But if you just need to like pull all the keys out, then you can just do like ... keys. And it'll effectively do the same thing.
I gotcha.
That's cool.
It reminds me of a lot of the stuff that I had to learn in my Lisp class, because it's the Lisp processing language. So most of it was just functions that already existed that you executed on lists. I don't recommend anyone learn that language because there are better languages nowadays.
Lisp, like L-I-S-T?
L-I-S-P. Lisp.
Oh, Lisp. Yeah.
Yeah. I recommend no one go and learn that, because while it has some useful things for helping you learn recursion, it itself is... There are better languages for writing things in.
You were kind of burnt by it?
Everything runs on one line of code that you execute, so it's very, very painful to debug. And while you do sort of build an environment by predefining functions, anytime I actually had to turn something in, they didn't want to have to execute multiple lines of code. So
that's the one with all the parentheses, right?
Yes, tons and tons of parentheses. Basically, you can execute a function on a set of data, but then you can execute a function on that function, which returns a set of data, and you execute a function on top of that function. And that's just a bunch of parentheses on one line of code.
Doesn't that get back to that, functional composition like you were talking about earlier, Dan?
Yeah, I mean that's kind of
I think that's the way Lisp works. It's like this long string of functions on top of functions, right?
mhm.
Yes, basically. Right.
Yeah, some like a language like Clojure. Have you ever looked at that? That's very similar. Like that kind of is a Lisp language. That yeah, it's all about transducers and composition, and it's just this crazy. Everything has a parentheses around it, so everything kind of is composed by default.
Oh yeah. See, that's at least a little bit better because you can at least separate it into different parts and then debug it. Whereas Lisp, you would have one set of parentheses around all of that, and it would all execute at once.
Mm-hmm.
Well, not at once, but from the innermost parentheses going out.
Right. Yeah, and this also runs on the JVM.
It looks like they took the better parts of Lisp.
Yeah, Clojure is really interesting. It was also, when I was talking about trees earlier, that's the internal data structure that Clojure uses. Or tries, rather. So it's all kind of like highly optimized for those kind of computations. This is cool. It'd probably be really good to learn some Clojure.
Yeah, like if anything, like I mentioned, that sort of programming helps you become a lot more familiar with recursion, because since you're already using a function where it's based on functions calling other functions, calling a set of data that's in the middle of all of that, it becomes easier to have a function call itself within that and use that. So it's harder for exact examples are something I'd have to work through beforehand before bringing them forth, which I might try to do that. If I know some topics that we're going to go into, I might try to work through some familiar examples before next session. Though I feel like I'm talking about less vague less vague abstracts and more specific examples.
Sure, I think anything like yeah, I mean really anything. I mean this group I think can be as open as we want it to be, and we can. I think later on the book is gonna like provide enough stuff where we're gonna be like pretty heads down and like putting our heads together to try to solve just some of the examples, but like in the earlier chapters at least, I feel like we can supplement, with any examples that you wanted to show.
Yeah.
That'd be cool.
Or just like something like I mentioned Big O earlier, but I didn't provide any exact examples.
Well, like even this next chapter coming up, objects in array. I mean, we could do some, comparative analysis of how JavaScript versus other languages.
Yeah.
That's always interesting to me. Here's what we're doing with this language versus C++ or Python or any of the other languages that have similar.
Yeah, Alexa knows some Python.
Yeah, just a little bit.
I don't know any.
I actually timed out. I lost connection, so I don't know what you guys are talking about right now. So I apologize if that was a decent response.
Sure.
Yeah.
I came back in right at Alexa knows some Python.
We were kind of talking about Lisps and then just other languages.
Python is definitely like JavaScript.
Yeah, we signed you up to do all the exercises in Python.
Oh, that'd be fun actually. Especially these three are pretty pretty simple ones. I like these ones.
Oh, I love looking at JavaScript versus Python.
JavaScript probably be about 3 lines shorter in Python, honestly.
Yeah, usually it makes Python look bad, or it makes JavaScript look bad.
But hey, JavaScript always has the browser as its safe space, so.
Oh yeah. Well, and with those like arrow functions and stuff now, I think JavaScript's arguably just as just as friendly, but there's still a few kind of edge cases and like pain points that
you
just have to go over more and more.
Yeah, JavaScript's just more quantity of characters on your screen.
Yeah.
That's basically it.
And remember, you can just leave off like the
semicolons.
Like semicolons, yeah, you can just take those off. Don't really need them. Works. That's the main one. Really, I mean, it'd be cool to see, in a different language, not having these parens around arguments.
You know what? You can. Are you saying you can do that in JavaScript, or you can't?
No, you can't in JavaScript. It's.
Yeah, in Ruby you definitely can, but it is frowned upon.
Yeah. Well, I mean, any language that uses parentheses to show us the arguments to a function, I don't think you're going to be able to take them away.
Well, in Ruby you can, and in Python certain functions you can, like print. In fact, they just added parentheses pretty recently, but it's really frowned upon, mostly because people are coming from these older languages that every argument had a parent. So something to show that it was an argument, not just like a variable or keyword. And so it's really frowned upon, other than certain frameworks like Rails. That's just doesn't. Tomato, tomato.
Yeah.
It all runs.
And you've done some Rails, right?
Alexa, yeah, that's my #1 thing is Rails.
Have you looked at Ember?
Not in the least. Ember.js?
Yeah.
Is it, no, I haven't even looked. I'm still on regular JS, so.
Ember looks pretty cool. At some point in the future, if you're looking for like a full stack framework, I would look at that because it's from Rails people. So the people that made Ember, I think, were trying to make a Rails-like JavaScript backend.
Interesting. Yeah. No, I was starting Meteor, so I'll finish that up.
Oh, sweet.
But Ember would be a nice thing to look at for sure. Yeah, this is a very user-friendly website. Just lots of white space. This is pretty good.
Yeah. Yeah, and it's pretty. I mean, if you're looking at at Meteor, it's pretty similar. They both use handlebars. And you get a lot of these like pre-compilers for free.
Sure.
Yeah. Yeah, it's pretty neat. It's quite a bit. It seems a little more monolithic.
Yeah.
Than Meteor, but they're doing all the stuff that everyone else is doing, like Angular and React, as far as like virtual DOM.
Sure. Yeah. That's actually pretty
data.
Cool.
Yeah. I don't know if they use JSX. Probably do something else. But yeah, I haven't looked at it too much, but I listened to a podcast and they were talking about Ember, and it was with Yehuda Katz is the creator of Ember, and he's like on the core Rails team. He works with David. What's his name? The Rails guy.
The Rails dude. Yeah.
Yeah.
Oh yeah, for sure. Yeah, I know who you're talking about. Don't know his name.
Heinemann or something. Or?
He's a Japanese guy. Oh, Rails guy. Okay.
Whoops. Not David Allen Co. Oops. Yeah, Heinemeyer. Hansen. DHH, that guy.
DHH. Cool stuff.
Cool.
Yeah, I'll actually have a look at Ember, see what it's about.
Might look at Clojure a little bit, see if I can answer one of the things in Clojure. It uses let.
There we go. We found something that uses let. Here we. Oh yeah. Oh, is Clojure JavaScript or is it its own thing?
It runs on the JVM, and it's kind of Lisp-like, I think we said. In that it puts parentheses around everything. I'm not sure what the difference between like the fat arrow and just the bracket arrow. I don't really know much about it other than it uses immutable data, and it uses those try structures that I showed earlier. And now I have too many windows open. These things uses this to like store data. Anyway, I'm kind of getting off the rails, so to speak.
Sure thing. Yeah, I'm gonna head out anyway right now. It's been a fun time.
Yeah.
Nice functional programming tonight, and we even look at what's next time? We did data structures. Okay, so chapter 4 is when it kind of gets mentally stressful, mentally acrobatic. Since we starts talking about.
Yeah, I think we'll have a lot more material from the book for next time with this chapter.
Yeah.
I mean,
he even goes into
like. It'd be good to go over through that. We could go through that weird squirrel example, and it's completely.
Yeah.
Yeah, for sure. And if anybody has taken statistics that can explain phi.
Not
I'd
me.
have to look into it again. It's been
I just
a year
had
and
to
a
take
half since I took statistics.
Yeah.
Yeah, maybe you can explain all that phi stuff.
Yeah.
In here.
I mean, correlation makes sense mentally, I think, anyway, but not the actual computation of it.
Yeah, the computation. I just had to take his word for it.
Yeah. So yeah, it'll be fun. It'll be fun next 2 weeks. We'll spend. And not only that, but I think maps, like I think I've said this before, is explained horribly in this chapter.
Oh, really?
I personally didn't like it. Maybe it works for everybody else. So we might just have to buckle down on this chapter.
Maps simply just applying one number to every single item in the array, right?
Wait,
if you're mapping
or
out
a function or a code block.
Oh,
yeah.
You mean like the map? Talking about the map function?
Yeah, the map makes sense to me. It just isn't explained well, I don't think. So if anybody else,
it's a simple concept, but yeah, it's maybe not explained so well in the book.
Yeah, that's one of the reasons I like this group.
Or maybe it might have just been the where squirrel.
No matter which sort of book that you get into, there's always going to be one or two concepts that's not going to explain as well as you could find elsewhere. And the fact that whenever we do run into concepts like those that the book might not explain as well, you at least get other sources that explain them differently, which helps you get a better grasp on it.
Absolutely.
It's one of the values I see here, that and fresh perspectives and outside information. So.
Yeah, totally. I love this group, and I am so grateful to you guys for coming and sharing.
It's fun to be here.
I wanted to say that.
Yeah, same for me. I get a lot out of this group.
And it's also very convenient.
Yes. Yes, indeed.
Yeah.
I like driving to Denton to see you guys for Node School, but that's a long wait.
Yeah.
Yeah, especially this month. Oh, yeah, Jay. From now on, it's all going to be on opposite weekends from Node School to the Arduino class.
Oh yeah, and that's what I thought. I saw this schedule, which means I probably won't be going to Arduino class. But David is talking about doing the Skype sessions for that too, similar to what we're doing here.
Oh, that'd actually be pretty cool for him.
Yeah, I want to be on that. Especially if it's on a weeknight.
Send him an email if you're interested. He can send out like a little questionnaire if people are interested in it. So, speak up if you are, because I would like to do that myself.
Yeah, for sure. I'm gonna do that. Let's see. There's a couple. There's a functional programming meetup happening on Monday. It's in Carrollton. This is actually really close to my house. Or my work, sorry. Ooh, and then there's a meetup on Happy. Happy's a backend framework. It's really cool. Oh, I was looking. I thought there was a robotics meetup coming up.
I need to remember to look up things on there. Give me some more stuff to do with my summer.
Yeah.
Makerspace has a ton of stuff. Dallas Makerspace.
Yeah, I thought they were having like a NodeBots thing.
I actually stopped subscribing to their.
It's too many things.
They had a lot of stuff flying at me. I wouldn't be surprised if they had anything. They could have cha-cha dance classes. And I believe it.
No, looks like they don't have any Node things. Product builders. There's a robot builders night out.
Yeah, that's actually a repeating.
Embedded workshop. Yeah, I'm just wondering. Have you been out there, Jay? Have you been to Dallas Makerspace?
No, I haven't been there yet. I would certainly like to go see.
Do you live? How far from? Well, it's kind of North Dallas. It's Are you located in Keller?
No, no, I live close to Wichita Falls.
Oh wow. Okay.
Yeah. So it's yeah. The closest place for me is Denton, and then in North Dallas, that's another 25 miles maybe.
Okay.
Yeah, like you see on there where Bowie is, right in the middle between Decatur and Wichita Falls.
Uh huh.
Yeah, right there, Bowie.
Oh, Bowie. Oh, okay.
Yeah, that's right.
Oh, cool. Okay. Well, I was thinking maybe Dallas Makerspace was closer for you, but it's very far.
Yeah, nothing is close to me. Rocks and trees, and that's about it.
Peace and quiet. Make it big.
Mm-hmm. Well, looking over Chapter 4, are there any other topics that we want to kind of prepare for? I made a little list of things like arguments, phi, maps, functor to kind of talk more about functional stuff. And I'll try to actually have like a lightning talk to give on something called mutability.
Now, chapter 4, I think it just needs to be done. So maybe send out a reminder to actually do the chapter.
Yeah, I'll do that in a couple days.
Like just be like, chapter 4 is the real thing, everybody.
Yeah.
Bring your A. It's not a drill.
This is not a drill. Yeah, people suffer from from this being ignored.
Actually, if you get here and you don't understand it, it's really disillusioning, I guess if that's the word.
Disheartening.
So, disheartening. There you go. Just come. Well, all right, y'all. I'm gonna actually head out. It's my bedtime, basically. So I will see you all in a week and a half, I suppose.
Cool. Thanks for coming.
Now you go ahead.
Participating.
All right.
See you next time. I'll send that reminder to you.
Yeah.
Thanks.
Yeah, I'm gonna cut out too. I got to go watch the news. I hear there's pandemonium on the House of Representatives floor.
Oh boy.
Go check that out.
Well, enjoy yourself. I think.
All right.
Yeah, I'm ready to stop. If anyone else has anything they'd like to add. go for it.
I think see you all next time.
Okay.
Later.
Take care.
Bye-bye.
Thanks for
Bye.
coming. I'll see you later, Paul.